Hello students, I welcome you all in this session of quick solution for All India AIATS test series for JEE Advanced 2020, test 6A, paper 1, code A and B, physics, test dated on 16th of February 2020. Straight away, let's proceed to question number 1. Here in question number 1, a metal disc of radius 25 cm rotates with a constant angular velocity of 240 radian per second about its axis in uniform magnetic field of 2 Tesla directed perpendicular to the disc. A load resistance of 5 ohm is connected across the center and the rim of the disc. The current through the resistance in ampere is. We must be knowing a very particular answer, and that is, if some disc or the rod of length L is rotating with angular velocity omega in uniform magnetic field B, then across this pivotal point and the free end, the EMF that will be developing, it will be B omega L square by 2. So with the same answer, I shall be saying this is the EMF that will be appearing across these two ends, and now it's been connected with resistance of how much? 5 ohm. So the current on this portion of the resistance, I would say it is E divided by R. The value here, E would be equal to B. How much it is? It is 2 Tesla. Omega is 240 into L is 25 centimeter. That means 1 by 4 into 4 in SI unit, and this is 2, and the resistance being 5. So 5 into 2 will cancel out. This is 2, 8, it is 3. So the value of current, it is 3 ampere. So for question number 1, 3 is the correct answer. Now let's proceed to question number 2. In question number 2, in the circuit shown, L is equal to 1 by pi microhenry and C is equal to 18 by pi microfarad. The left hand capacitor was charged to a voltage of 20 volt, and then at t is equal to 0, the switch S is closed. The time in microsecond at which voltage on right hand capacitor becomes 5 volt is. Let's have a bit of elaboration here. One very important thing that is clear, it is the circuit is a LC oscillation circuit. Fine. With the angular frequency, I would say it is omega would be square root of 1 divided by L into C equivalent. Here the C equivalent would be taken as the series combination of these two capacitors, so definitely it will be how much? C by 2. So I'll calculate here the value of omega to be equal to, it is square root of 2 divided by L, L being how much? It is 1 by pi, here it is 10 to the power minus 6, and C is 18 into pi into 10 to the power minus 6. So omega, I'm getting this value here, it is pi into 10 to the power 6 divided by 3, it is in per second. Okay, now first this capacitor was fully charged. It will try to drive the current along this direction, and the current will keep on growing in inductor, and it will reach a maximum value when di dt will be 0. What we know here, the potential drop across the inductor will be taken as L di dt, and this is the potential drop across the inductor. It must be the difference that is actually appearing across these two capacitors. So by the time when L di dt will be 0, the one thing is very clear, that it is the charge on these two capacitors must be same, or in other way I would say the voltage on these two capacitors must be same. Since the initial voltage was 20 volt, so I would say the voltage here would be how much? 10 volt, and voltage here would be 10 volt. This is the time instant when the current here in the inductor will reach its maximum value. So what actually has happened, in inductor current started from 0 value, it will reach its maximum value at exactly the time when the voltage on these two capacitors will reach the value of how much? 10 volt. Then from there onwards, as the direction of current was along this direction itself, the current will keep on decreasing on the inductor, but it will again in the same direction. So we shall say the current now will try to decrease, and it will come to 0 value. and by the time it will come to 0 value, I would say this capacitor will now be charged to its maximum value, and that is how much? It is 20 volt. So actually what has happened, charge will keep on oscillating from this capacitor to this capacitor, and the time when the current will reach its maximum value in inductor, at the time the voltage across both of these two capacitors are same, and that is how much? That is 10 volt. So 2 or 3 important things that actually we have concluded here. The first part was, it was the equation of SHM with angular frequency how much? Omega. Another thing is the voltage on this capacitor, if I am taking this part to be as the reference, it is starting from 0 value. It will reach a value of 10 volt at the time when the current in the inductor has reached its maximum value. That means 10 volt is the average value of the voltage across this capacitor. So what the situation is, started from 0 value, 10 volt is the average value, and then again once the capacitor will be charging, furthermore its potential difference will reach to 20 volt. So 10 volt to 20 volt, then 20 to 10 and to 0. This is the way the voltage will keep on oscillating on this capacitor. Fine. So what is the equation now? We already had the angular frequency, we are already having the amplitude of oscillation, that is 10 volt here. Now we need to find what was the initial phase of oscillation for this capacitor. So we can write it down as V is equal to average value is how much? 10, and this is amplitude being 10, it is sine of omega t plus phi. Okay, this is the equation for the time being. Now we need to find the initial phase of oscillation. Okay, here if the initial point here, if at the initial point, if the voltage on this capacitor would have been 10 and it will be increasing in this direction, then certainly the initial phase of oscillation would be how much? 0 itself. What about if it is starting from here? It will be the phase of pi by 2. And what about if it is starting from here? It will be a phase of how much? Minus pi by 2. So I'll just write it down, the phase at this particular instant, because at initial time instant the voltage on this capacitor is actually how much? 0. So I'm writing down it as 10 plus 10 sine of omega t minus pi by 2, or finally V is equal to 10 minus 10 cos of omega t. This is the equation of the voltage across this capacitor. Fine. Now let's proceed with the calculation of the time in microsecond at which the voltage on right hand capacitor becomes 5 volt. Just place this value to be 5 volt here. We'll be getting this answer as 10 cos of omega t will be equal to 5, or cos of omega t will be 1 by 2, or omega t is actually pi by 3. So how much is the t? It is pi divided by 3. Omega was pi into 10 to the power 6. Here it is 3. So this will cancel out, and time we are getting this answer to be equal to 1 microsecond. Fine. So for question number 2, we are getting this answer as 1. Now let's proceed to question number 3. In question number 3, one surface of an equiconvex lens of mu is equal to 1.5 and r is equal to 20 centimeter is silvered. When an object is placed at a distance x centimeter as shown, a real image which is 2.5 times magnified is formed. Find the value of x. We are having a lens and a concave mirror like this way, and they are attached together, and the combined system will now behave like a concave mirror. The refraction will be taking place on the lens first, then the reflection from the mirror, and again from the lens, and finally the ray will be converging somewhere around here. So what we shall say, the two different powers of the lens will be added and the power of mirror will be taken for the combined system. Let's first have the calculation for the focal length of the lens, or alternatively I can say the power of the lens. I would say here 1 by FL would be taken as mu minus 1, 1 by R1 minus 1 by R2 with proper sign scheme. We'll be getting this value to be equal to 1 by 2. This one is 1 by 20 and R2 is minus 20, so I would say 1 by 20. So we'll be getting this value to be 1 by 20. Fine. And the focal length of the mirror, how much it is? It is Fm is minus of R by 2, that means minus of 10. So now equivalent power P would be twice of power of lens plus power of mirror, and the combined system will now behave like a concave mirror. So I would say twice of power of lens, that means P is equal to 2 divided by 20. What about the power of mirror? It is minus of 1 by F. So I would say it is minus of minus 10, that means it is 1 divided by 10, or P is actually 4 divided by 20 or 1 by 5. And this system is now behaving like a equivalent concave mirror. So what about the equivalent focal length this time? It is F equivalent is minus of 5 centimeter actually. Now let's proceed for the calculation now. When an object is placed at a distance x centimeter as shown, a real image which is 2.5 times magnified is formed. Find the value of x. I would say 1 by v plus 1 by u is equal to 1 by f. This is the equation for the mirror now. What it's been said, object is placed at a distance x here. Real image which is 2.5 times magnified is, that means the real image will form on this direction itself. So I would say v to be equal to 2.5, that is 5 into 2x with a negative sign. U is how much? Minus of 1 by x, and f is equal to, it is 1 by 5. So by solving we'll be getting this value to be equal to 7 divided by 5x is equal to 1 by 5, or x is equal to 7. That's the answer we are getting. So the find the value of x, that means the value of x is coming out to be 7. That's the answer for question number 3. Now let's proceed to next question. In question number 4, an annular disc of mass m, inner radius r and outer radius 2r is pulled by a force F as shown. If it rolls without sliding, then frictional force acting on the disc is given by F is equal to n into capital F divided by 13. Find the value of n. First we need to find the moment of inertia of this annular disc about this contact point. Okay, let's say the total mass is m and it is distributed uniformly on this surface, then the mass density would be m divided by 3 pi r square. And if I assume the whole of the system to be filled up completely, then total mass would have been m dash would be 4m by 3. It means this portion that actually has been removed is having the mass of how much? M by 3. So the moment of inertia of whole of this part about this axis first. It is mass being how much? 4m by 3. M, r is 2r, so it is 4r square divided by 2 minus this one is m by 3 r square divided by 2. So I about this axis would be mr square by 6 here. 16 minus 1, it is 15, or I is 5 by 2 mr square. So what about the moment of inertia about this contact point P? It is IP would be 5 by 2 mr square plus m. This distance is actually how much? 2r. So it is 4r square, and we are getting this answer to be 13 mr square by 2. Now because of this force, the whole of the system will try to rotate about this point. Let's say alpha is the angular acceleration, and since it is executing the state of pure rolling, a will be the linear acceleration with the relation a is equal to alpha r. So I shall be writing it down as f, this distance is 4r here, must be equal to I 13 by 2 mr square, alpha is a divided by 2r. fine. This one will cancel out, and we are getting A to be equal to 16F divided by 13M. Now this is the acceleration of the center, and it must be provided by the action of this force F and the friction force acting here. So I would say F plus small f, this is the friction here, must be equal to M into A, that is 16F divided by 13. That means F would be equal to 16F divided by 13 minus F, or it is 3F by 13. Comparing this equation with the one given in the question, we are getting the value of N to be equal to 3. That's the answer for question number 4. 3 is the answer. Now we shall proceed to question number 5. In question number 5, the equivalent resistance between points A and B for the given circuit in ohm is. We need to find the total current flowing across this end A and B and the potential difference across A and B. Simply, then we shall divide those of the two ratio. Well, let's the current here in this segment is I1 and here it is I2. Then by a cross symmetry, the current here will be I2 and here it will be I1, and the current here it will be I1 minus I2. So for this particular loop, I would say minus 5I1 minus 5I1 plus 5I2 plus 10I2 must be equal to 0, or 15I2 would be equal to 10I1, or I1 would be equal to 3 by 2I2. So the total current that must be flowing across the segment, it would be I1 plus I2, or 3 by 2 I2 plus I2, or it is 5 by 2 I2. This is the total current. What about the total potential difference across A and B? It is delta V. It must be 5I1 plus 10I2, or 5I1 was how much? It is 3 by 2I2, that means 15 by 2I2 plus 10I2, or it is 35 by 2I2. So effective resistance R equivalent will be delta V by I. It is 35I2 divided by 2. Here it is 5I2 2. This one will cancel out, this one will cancel out, and we are getting R equivalent to be equal to 7 ohm. So for question number 5, 7 is the correct answer. Now let's proceed to question number 6. In question number 6, an open tank is filled with two immiscible liquids as shown in figure. A small hole is to be made in the tank so that the liquid hits the ground at maximum range. The height of the hole is given by h is equal to small n h divided by 2. Find the value of n. We'll try to explain it by two different cases. Let's first assume that whole of the liquid is of density 2 rho itself. Then for that case, the equivalent height would have been, here it was 3h and this is rho and 2h, so I would be saying it is h only. So the total height would now be considered at 4h. So what we know in that particular case, the maximum range would be when it will be held at exactly half of the height. That means this height would have been how much? It is 2h. And in that case, the range R1 that actually comes out to be, this is 16h square. Actually it happens to be how much? 4h. That is the range we will be getting once we'll assume that whole of the liquid is actually of the density of 2 rho itself, and it's been pressed at this particular point. That means at the height of 2h from the bottom. Another way, if now at any particular point which is quite different from here, if it's been pressed or it's been held, then certainly the range will be slightly less than this R1 found here. Okay, but here the situation becomes different. Once suddenly we just pass across this interface, here the liquid that will be coming out is of density rho, and so the velocity here would be how much? V would be root under 2g into 2h. This is the velocity with which the liquid will be coming across here. And the depth it will be traveling here, it will be 1 by 2 gt square would be 3h, and the travel time will be 6h divided by g square root of that part. So the range this time, it will be square root of 4gh here into 6h divided by g, and we are getting this time it is 24 into h square. So clearly looking into this situation, once we try to move along this direction, by the time we'll just cross this interface, suddenly the range becomes R2 and it happens to be square root of 24h square. That means definitely if it's been pressed or it's been held at this point itself, then we'll be getting the maximum range. So as per the question, height of the hole is given by, this is the height actually, how much it is? 3h. So comparing this with the answer we are getting h6 capital H divided by 2, that means the value of n we are getting as the answer is 6. Fine. So for question number 6, 6 is the answer. Now let's proceed to question number 7. In question number 7, the time period of oscillation of system shown in the figure is given by t is equal to 2 pi square root of 11m divided by nk. Find the value of n. We need to find the equivalent restoring force once the mass would be displaced slightly by a displacement x. Let's say in that process, this particular spring gets a displacement or extension of x1, and this one is having the extension of x2. So by taking into account of the fact that tension in this spring and string will become same, we can say kx1 must be equal to 2kx2, or I would say x2 will be equal to x1 by 2. Fine. Now let's say this spring is having the extension of x3. So in that case, the tension over here, it is kx3 must be twice of this tension, that means 2kx1, or I would say x3 is equal to 2x1. Now if this mass is displaced by x, then I would say it is x2 plus x1 divided by 2 plus x3 must be equal to x, or x2 by 2, that means x1 by 4 plus x1 by 2 and plus x3, that means 2x1 would be equal to x, or it is x1 plus 2x1 plus 8x1 divided by 4 is equal to x, or 11x1 divided by 4 is equal to x. Now what about the restoring force in this mass? It is F restoring would definitely be k into x3. Fine. And F restoring is k. What about x3? x3 is 2x1 and x1 is 4x divided by 11. So F restoring, we are getting it to be 8k by 11x. So effective spring constant is 8k by 11. So the time period would be t is equal to 2 pi root under m by k equivalent. It is 8k, here 11. So by comparison, we'll be getting the value of n to be equal to 8. That's the answer for question number 7. Now let's proceed to question number 8. In question number 8, an ideal monatomic gas is expanded so that the amount of heat supplied to the gas is equal to the decrease in its internal energy. The molar heat capacity for the process is given by C is equal to minus kR divided by 4. Find the value of K. This is simplest of the question here. It's already been given that the heat supplied dQ is equal to decrease in internal energy. If I'll write it down as NC dt, C being the heat capacity, then it would be minus of NCV dt, or C must be equal to minus of CV this time. It is for ideal monatomic gas. We know that CV happens to be 3 by 2R. That means C this time it is minus of 3R by 2. Have the comparison here. The value of K that is coming out to be, it is 6. So for question number 8, 6 is the correct answer.